Hello everyone, we are going to see the complete electromagnetic spectrum. To understand the complete analysis of electromagnetic energy, let us see some facts. In this video lecture, we will see electromagnetic energy, type of electromagnetic energy in detail, and some important fact about the electromagnetic energy. Since we know that in the universe is only composed of two things. These two things are matter and energy. Matter we have seen in mechanics about matter in detail, but electromagnetic spectrum speaks about energy available in the universe. This energy is of various type. Here in this energy, some energy is visible, and rest energy is invisible. In visible energy, there is only light energy, and in invisible energy, there are various parts. Visible light is this. Visible energy is very small part of electromagnetic spectrum. Very small it is, very small part. Since this electromagnetic energy in universe is travel in form of wave, and wave velocity of this electromagnetic energy is denoted by c, and wave velocity is given by frequency nu and wavelength lambda. Nu denotes frequency and lambda denotes wavelength. This frequency nu and wavelength lambda and c is speed of electromagnetic wave. This electromagnetic wave is divided on a scale of frequency and wavelength range. Here is a diagram to understand the complete electromagnetic spectrum. In this electromagnetic spectrum, when we move from left to right in the diagram, its wavelength lambda increases. When we move from left to right, and it is in scale given 10 to the power minus 15 meter to 10 to the power 8 meter, and in same range when we talk about its frequency decreases. Moving on left to right, if we see the complete wavelength range, on the left it is minimum 10 to the power minus 14 meter up to 10 to the power 8 meter. And if we talk about frequency, it is from 10 to the power 22 hertz to 100 hertz. it decreases a lot, whereas the wavelength increases in the complete. This whole picture is known as complete electromagnetic spectrum. This spectrum, there is a visible spectrum and invisible spectrum. Visible spectrum is very small and it is given from violet to red. V2R here in it, and rest on both sides is invisible energy. We are taking one by one in this complete electromagnetic spectrum. If there is no clear boundary between two electromagnetic energy, we will discuss in this. Here is one. Approximately from here to here, 10 to the power minus 14 to 10 to the power minus 10 is known as gamma rays. Let us see this gamma rays in detail. Since from the left it is first electromagnetic energy known as gamma rays. We will discuss under 5 points. The first point is wavelength range. The wavelength range is from, as I told, 10 to the power minus 14 to 10 to the power minus 10 meter range. So wavelength increases, whereas when we talk about its frequency range, it is 3 into 10 to the power 22 hertz to 3 into 10 to the power 18 hertz. So moving from left to right, the wavelength range increases while frequency decreases. See how it is produced. Gamma ray is produced by radioactive nuclei. The transition of gamma rays from radioactive nuclei. The property, this X-ray affect photographic plate. When it strikes on any object, emits fluorescence light. It has very high penetrating power because it has very high energy. It carry very high energy E. Energy is dependent on frequency. Moving left to right, frequency decreases, means energy decreases. It has no charge, it is complete energy. It affects the human body, and main important its uses. It is used to study the structure of atomic nucleus. Electromagnetic spectrum after gamma rays, there is one more ray up from here to here. This ray is called X-rays. It is discovered by Professor Rajan. See, very important. We are dividing in at a name of wavelength and scale of frequency, but there is no clear boundary between these two electromagnetic rays. See, gamma rays and X-rays, this is the intermingling part. No clear cut boundary. But a range is given. See in the detail about this X-rays. There, first of all, in this X-ray, first one is its wavelength range. The wavelength range of X-ray is 1 into 10 to the power minus 11 increases to 3 into 10 to the power minus 8 meter. Increasing minus 11 to minus 8. In that condition, its frequency range decreases from 3 into 10 to the power 22 hertz to 1 into 10 to the power 16 hertz. So X-ray has less energy than gamma rays. Gamma rays carry maximum energy, but it also carry the energy. X-ray production, it is produced when fast moving electrons minus 1 is 0 is stopped by certain material. Then in that condition, this material emits X-rays. Properties of X-ray. Since X-rays has high energy, due to high energy, it has a high penetrating power. And it is high penetrating power, but not as gamma ray. High penetrating power and chargeless, same like as harmful to human. Now this is time to see the uses of it. The uses of X-rays, the main use is, since its penetrating power is such that it can penetrate past the muscles but unable to pass the bones. That is why an X-ray photocopy image of bones is obtained. Second use is, it also used to see the structure of inner electron cell, SPDF, and it's also used to structure the help to study the structure of crystals. Now see the third one, that is small in comparison to gamma rays and X-rays. It is ultraviolet, less space. That is why ultraviolet is written by UV. Its name is ultraviolet because this is the visible spectrum, and violet to red, it's obtained beyond the violet. That is why its name is ultraviolet. And the ultraviolet radiation has following properties. Let us see very carefully. Ultraviolet radiation, which is found here in this spectrum, it has a wavelength range from 10 to the power minus 8 to 10 to the power minus 7 meter. Frequency range is from 3 into 10 to the power 16 hertz to 8 into 10 to the power 14 hertz. This frequency. Production, natural source is sun, arc lamp, vacuum spark through which this ultraviolet is produced. Properties. See the property of ultraviolet rays. Ultraviolet rays is also denoted by UV, and that UV is written here in the spectrum. All properties of X-rays and gamma rays, but in a small amount. amount. Now fourth one, that is the visible spectrum from violet to red. Very small range. When we see in the detail for the detailed analysis of this visible spectrum, then it will be very clear to us wavelength range. From 4 into 10 to the power minus 7 to 8 into 10 to the power minus 7. Order is the same. Same like as in frequency. 8 into 10 to the power 14 to 4 into 10 to the power 14. Production. Natural source is sun. When atom is excited and then again de-excited emits light. Properties. Various properties are shown by reflection, refraction of light, diffraction, interference, photoelectric effect, polarization. Number of properties are shown by this. Uses. The light energy, visible light, is used to see the object, atomic structure analyze, and many more work is done by the help of visible light. In spectrum analysis, after red, violet to red, this is one of the range. It is called, beyond the red, it is called infrared. See the wavelength range. The detail of this wavelength range and other is given here for infrared radiation. See carefully, it is from minus 7 power to minus 3. Large range. Frequency has also 10 to the power 14 to 10 to the power 10. Production. Natural source is sun. Infrared radiation, this is also known as heat radiation, is emitted by the hot bodies. The properties, some properties similar to the light, reflection and polarization phenomena can be obtained by it. And the property uses of this infrared is used in radar for communication purpose, long distance communication, microwave oven. This is the heat radiation, so it is used to heat the object. After infrared, from here to this line, 10 to the power 0, the wavelength range is called microwave. Microwave are also called short radio wave, and the properties of this, see the related terms used in it. Wavelength range 10 to the power minus 3 to 10 to the power minus 1. Frequency range minus 11 to plus 10 to the power 11 hertz to 10 to the power 9. This microwave is produced by electromagnetic oscillators in the laboratory. Properties: radio detection and ranging, radar, long distance of communication, and its properties is reflection and polarization, and the uses of this is radar, long distance communication. After microwave, see the wavelength range from here to this. This signal is called radio wave, this electromagnetic energy. And these radio waves have the following properties. Radio wave have a following property. its wavelength range -1 to 10 to the power 4. 10 to the power 4 meter means up to 10 kilometer long single wave. And frequency range 10 to the power -22 from gamma rays. Remember, it decreases up to 10 to the power 4. Very small. Production range. Production of this. It is produced by alternating circuit. If it is oscillation of alternating circuit, produce radio waves. Properties: phenomena of reflection and diffraction is shown by this slide. It is used for communication purpose in radio and television. The signals are sent, the radio signals and TV signals are sent in form of radio wave. See, after radio signal, there is long wave, lies in this range. It is the properties of long electromagnetic wave are wavelength range in meter, frequency range in hertz, small range. It is production used by weak oscillation of alternating current circuit. Telecommunication signals. It is used by, and it has a various range. This various range is their names: extremely low frequency, very low frequency, medium frequency, high frequency, ultra high frequency, super high frequency, and extremely high frequency. Although it has a very small range, but it is divided in a number of categories, and that category is used for different signals to send for different telecommunication purposes. This is about whole electromagnetic spectrum, in which gamma ray, X-ray, ultraviolet ray, visible spectrum, that is light rays, infrared, microwave, radio wave, and a large variety of long waves. I hope you enjoyed well. Thank you and have a nice day.